This is part 3 of the C# version of the White Belt Kata. What we're going to do is we're picking right up where we left off on part 2. We're going to do the last 4 steps. We want to make the test pass. We're going to do a refactor. We're going to make the app run again, and then one more refactor. So let's go ahead and head back in. Again, this might be a good place if you're creating templates. If you ran through those previous 4 steps, you might go to Windows Explorer, copy out the solution folder somewhere, and have a template ready to go for yourself so that you can practice these last 4 steps without doing everything on your own. Once you get this last video under your belt, then you want to actually run through the whole thing starting from scratch. And your goal is to do it without any of the videos. All right, so let's move in. We've got our test. It is failing. So our next goal, step 7, is we want to make the test pass. This is basically writing the prime number code itself. This is going to look very different depending on what we do and what algorithm you use, what you look at. This could look very, very different. I'm going to show you just one of probably a million ways to solve this particular problem. So first off, we know we need to get rid of the throw new not implemented. Let's talk through what we really need to do. Let's pseudocode it out. So what we need to do is we need to basically, we're going to run through a bunch of numbers and create some collection of those as we go. So we're going to need to create a place to store prime numbers as we find them. Then we're going to go through all the numbers from 2 up to max prime numbers. So go through from 2 to max prime number. So some sort of loop that'll go 2, 3, 4, 5, 6, all the way up to prime number. Then for each of those numbers, for each candidate, each possible prime number, then what we're going to do, and I'll just tab this in a little bit, is we're going to say if, what are we doing? If, so this is a whole complicated thing to determine if it's prime. I'm going to make that a method. So if is prime, possible prime number. So we're pseudocoding a little bit. So if it is, then add possible prime number to our list. Once we get through everything, we'll simply return the list. That's basically it. Now this is going to need to create some isPrime method. So let's go ahead and start pseudocoding that out. So isPrime, and this is going to take some number, and it's going to return, well, we're using it in an if, so it's going to return a Boolean. So let's go ahead and just do that really fast. So there's our method signature. Returns Boolean. The name is isPrime, and it takes a number, and this is going to be a whole number. So there's our method signature. What are we doing here? We're going to basically go through the numbers starting at 2, up to the number, but not including the number, and we're going to see if it's evenly divisible. So go through from 2 to number minus 1. We don't want to go all the way to the number. We want to go to the number below number. Because if we test for number, it's of course going to be divisible by itself. That doesn't make sense. So we're going to go through each one of those numbers. Then for each, what is this? This is maybe a factor or a number that we're checking. Let's call it factor. For each factor, 2, 3, 4, 5, whatever it is, for each factor, we're going to say if the number that we're checking divided by the factor remainder, so this is going to be the modulo factor, gives us no remainder equals 0, then we're returning false. It's not prime. Otherwise, if we complete the whole thing, we return true. So that's pretty close to the code we're looking for. So this is basically pseudocoding it out. This is the algorithm we're using. This pseudocode does not really change language to language. The code itself is what's going to change. So let's go ahead and start writing through this. First off, we need to create a place to store the prime numbers. So let's create a var. Actually, this is going to be a list event 32. I know that because that's our return type here. So we're going to create a list event 32. Let's call it prime numbers found. We're going to initialize this to an empty list. So just straightforward, open, close. So that's all we need on that line. The next line is we're going to go through from 2 to max prime, and then for each. These two, we're actually going to do together. I'm going to do these as a for loop. You don't need to do that. You could do these as 2 steps, but I'm going to do this as 1 step. So we'll say for, and I'll just do var, and this is possible prime number. I like that as a name. So let's do possible prime number. It starts at 2. We'll say possible prime number less than or equal to max prime number. Possible prime number plus plus. It is helping me out. Now at the end of this line, we're going to have an open curly brace. If it gives you a close, delete that close. So we just want the open curly brace. Then we're going to close the curly brace right before this return list. So let me go between those two. We'll close that, and now it's going to indent these for us, which is great. Now I can move on to these, or I can do the return list. Let's go ahead and move on to these. So the next one, if is prime. So we'll say if, well, sure enough, there's an isPrime method that we're going to create. That seems good. We'll pass possible prime number, and again, create our curly braces. And we want this line to be in between. All we're going to do is add. So we'll say prime numbers found dot add possible prime. So if it's prime, we add it to the prime numbers. Finally, return the list. We'll return prime numbers found. So we've now created the code for our pseudocode. You're welcome to delete the pseudocode if you'd like. You can keep it in there. I'm going to delete it so that actually I'll do that as a refactor. So I'm going to leave these in for now just so we can see how everything works through. Now it's still complaining because IsPrime does not exist. Well, that makes sense. I haven't created this yet. So let's go and create this method. Now I can either control period and let it generate it for us, or I can generate it by hand. Instead of, I do recommend generating it for you. That is great to do. I'm going to do this one by hand though. You're welcome to do this and then just change what you need to. So I'm going to create private. I'm going to do it as private because we don't know that we need to expose this publicly. So we'll say private. This is going to be Boolean IsPrime int32, and this is just going to be a number. Everything in here is going to be on the inside of that curly brace. So make sure, again, if it gives you a curly brace, delete that, close your curly brace at the end. All of this should be indented underneath it. Then we're going to run through for 2 to number minus 1, and then for each factor. So again, I'm going to do a for loop and do these in one line. So for var factor is a good name. It starts at 2. Factor less than number, that's number minus 1. So less than number, factor plus plus. And we'll move the closing curly brace down here. If number mod factor, well, this is basically our code. So if number mod factor equals 0, we will simply return false. Otherwise, return true. I'm starting to pick up pace because a lot of this actually looked like the code that we want to write. So this is basically what we're looking at. We have our method. Our pseudocode is helping us figure out what we want to write. We wrote the code for it. Now we have the C#. This looks about right. Let's go ahead and make sure it builds. So we'll do a build solution, Control-Shift-B, F6, build solution. We should get a build. Yep, build succeeded. Then let's head to our test explorer. Let's rerun. All right, I'm done. You may not be done. If you type something in incorrectly, you may have a problem, and that's okay. It just means that we need to figure out where that problem is. This step is generally the longest in the real world because we don't always get it right the first time. I've done this so many times that I can do it basically from memory, but you don't always get it right the first time. So whatever you think you messed up on, you'll need to check the number. So let me show you an example. If this were less than or equal to, let's say I didn't do that as less than, this is going to give me a failure. What it's going to look like is, the number of elements did not match. We expected 8, and we actually got 0 prime numbers. None of them were prime. Well, none of them are prime because we're testing the factor that is the number. Every number is divisible by itself. Another thing that you might have, another error that's very common is if this is less than rather than a less than or equal to, this will also result in an error. And it'll say the elements do not match. We expected 8. We found 7. What happened in this case? Well, looking at the numbers and debugging, what's happening is it didn't include maxPrimeNumber, that number 19 that we wanted to include. It didn't include it, so we missed one. That's why we do the edge case testing. So lots of things that could go wrong there. You may have a different problem, but the goal is to keep working through it, help iterate through it until you can figure out how to get your test to pass. That is step 7. We now make it pass. Step 8 is a refactor. So refactor is a fancy word that basically means change the way the code looks without changing the behavior. So now that we have a passing test, we're going to change some things in the code and we're going to rerun the test and make sure it still passes. And if it doesn't pass, we're going to undo what we did. So let's go and clean up some things. I'm going to head back to the prime number calculator. There's a few things here in this file that we can clean up. We can use the error list to give us some information. And here's one. Remember, IsPrime does not access instance data and can be marked as static. Okay, well, that's interesting. There's another thing up here. We've got a namespace that's not being used, so we can clean that up. And we can clean up these comments. We don't need these anymore because the code says what the comment does. And anytime you have code and comments that say the same thing, you want to get rid of the comments. Because if those get out of sync, you're going to confuse people. So we're going to get rid of these. Comments are good to include for why we did something, but not what it should be doing. So let's go ahead and clean up a few things. I'm going to get rid of the using statement. I can delete it, or again, control period. It's my favorite shortcut. We want to remove unnecessary usings. So it gets rid of that for us. That's a great refactor. I've got these comment lines. I'm going to just get rid of every comment line. Select them, delete, select them, delete, select them, delete. Just get rid of these comment lines. All right. That looks good. Now, before I move on to make sure I didn't mess something up, I'm going to rerun the test and make sure it still works. Really good to do every now and then. If I did mess something up, let's say, for example, I deleted too many lines. This is actually going to give me a build error. Oh, yeah, I've got a build error. Nope. I'm going to go back, and I'm just going to Control Z until I get back to something that was working. Make sure it works, and then go back again. So now that this is up and running. Okay, now I'm passing. Now I'm going to go back in. Okay, delete again a little more carefully this time. Maybe do it in batches. Run it again. Make sure it still passes. Okay, it still passes. Go back in. Keep doing my cleanup. Now I'm a little safer because I did something that made it fail. Save, making sure it passes again. Again, if I mess up, Control Z a few times to get back to a good state, and we're in good shape. All right, now there is one more refactor I could do here. IsPrime, it's giving me a suggestion. So again, if I do a control period, it's got a few different suggestions we could do. This particular method we could make static. It's up to you if you want to or not. I'm gonna do it just to get rid of the warning or the info message, but it's not that big a deal. So we'll make this static and then just make sure everything still works. Now doing that, it makes this now say, hey, this could also be static. You're not using that for anything. You're not using an instance method. So this could cascade up. I'm going to leave it alone, though, because we're calling this as an instance method, and I don't want to have to break everything that's happening in the test. That's good enough. So refactoring is a judgment call. This feels like some good things that we want to do here. Methods, I'm going to get rid of the line between them. I am going to add a line up here for methods. I like to do that to say, okay, these are all my methods, and they are alphabetized. So F comes before I. You can also see that in the list up here, so you can see the members, and it'll tell you what the order is. This is always alphabetized. Your code may not be. I like for them to be alphabetized. That way it's easier to find things. Looking back at our test, I don't think there's anything really we need to refactor here, although I could add, let's add a test methods method here. So if we wanted to add another test, let's say we wanted a public void find prime numbers up to 29, right? I could add a new test method here and then run through that as well. So test methods is kind of a good comment line. Once you're done with your refactoring, you're good with step 8. If you don't do any refactoring, I at least want you to tell me this is the refactor step and I'm not changing anything. You need to at least call out that we're doing the refactor step. Let me move my face back down. So that's the refactor. So we're just cleaning things up, make sure it still passes at the end of it. Step 9, we're going to make the app run. So this is the actual up to 100, making the application run. Back into the code, this is going to be in Program.cs. What we're going to do is from our tests, we're going to copy the first 2 lines of, or maybe 3 lines or 5 lines or 1 line, however many this first paragraph is. You're going to copy this first paragraph from your code and we're going to put it into Program.cs. I'm going to get rid of the console write line. We'll paste that in. When you paste it in, it's going to include this using for us so that everything's working in hunky-dory. Now here, we're not going to 19. We want to go all the way to 100. So we're going to change that to 100 because that's the actual prime number. And then finally, we need to display the prime numbers to the user. To do that in C#, Java as well, we can't just print an array and have it display everything. That works in Python, it works in JavaScript. It does not work in Java or C#. So we're going to actually have to loop over these numbers and display each one of them individually. So let's just write that out. So I'm going to write console write line. Here are the prime numbers. And then we're going to loop over them. I'll just do a for each prime in actual primes. We're going to console.writeLine, the prime, and then we're done. That's basically it. So this should run through everything we need to do. Now to make sure it doesn't close on me, let's just do one more thing. Write line, press any key to close. We'll do console.read key. So any key they press will finish the application and close it. You don't need these are not critical, but it's always nice to know that, okay, when you're done, press this and now we'll close the application. Now that we've got that, we need to run this. So a few different ways to do that. You can hit F5. You can go up here. This should say console app, which is the name of the main project. You can go to debug and start debugging. So lots of different ways to do this. I'm used to F5, so I'm just going to hit F5. It's going to debug in. Boom, there's our output. Here are the prime numbers, 2357, 83, 89, 97. If you've done everything else, this should be a really simple step because you've already done all the work to calculate it. It should come out straight away and be good. If it's not that, then there's something else we need to fix. So we'll close to close the application. That's it. That's step 9. That's all we need to do for step 9 is just display them to the user. Step 10, we have one more refactor. Again, if you don't have any refactoring you want to do, just call it out and say this is a refactor step. There's nothing I want to change. This would be a good time to look at anything and say, is there anything we want to refactor? Well, okay, let's see. For my for each, I don't need the curly braces because it's a single line, so I can get rid of those. That seems like a good refactor. I like that, a little cleaner. Let's go back to refactor. Same thing here. This is a single line if. I'm going to get rid of the curly braces. That's condensed. Same thing here, if line inline, so I don't need the curly braces. That's some good refactoring. Yeah, I think this all looks good. If I didn't like this number, maybe I could rename it. So all sorts of things we can do here. That's step 10. We're refactored. That concludes the White Belt Kata in C#. Again, great steps. So these videos, hopefully they've broken it down. Step 1, or the video 1, is going through the first 2 steps. Do that over and over again until you get really good at it and you don't need the video. Take that output, create a template. Let's go to Windows Explorer, create a template, then do step 2, or part 2 video. copy that template folder, use that for the video, and then delete that folder when you're done and go back and use that template folder again. Do part 2 video over and over until you can do it without the video. Part 3, same thing. Once you're done with the part 2 video, create a copy, create a template, then copy that out and do this video over and over until you get it down and you don't need the video. Once you're done with all of those, you're ready to do it from end to end. Also, feel free, once you get through these and do it a few times, feel free to use the faster videos. They're much shorter, much more condensed, so you can go much more quickly. If you're kind of getting used to things, that's a good way to see if you can keep up with that video. That's a good test to see if you're doing things. If you get really, really good, you want to see how fast you can do this. I think my record is a little under 5 minutes. I think I did it in 3 minutes and change at one point. So see how fast you can get it. If you can get down under 15 minutes, you're really in good shape for the white belt test. Good luck.